So next we're just going to simplify, and the Vy is equal to about 8.9 meters per second. Okay, and just to remind us what exactly this number means, this is the velocity of the y component, or if you were to split this speed up into the x and y components, the x would be down here, and the y component would just be the velocity, upwards velocity of the ball. And this is going to be the velocity that we're going to use to calculate the maximum height of the arrow. So now that we have the velocity in the coordinate system that we want, next step is to find the correct formula. So we have final velocity, initial velocity, acceleration, and time. So this does seem like something that we can probably use, but it doesn't quite work out exactly what we want to, because we have this uses time and we do not have time. So this one has final position, initial velocity, time. Again, we don't really have time, so let's just keep looking. We have the final velocity, initial velocity, acceleration, and difference between the distance. So this one I would say sticks out to me more, because we do know the final velocity, we know the initial velocity, and we do know the acceleration. So this difference, the xf minus x naught, or we could change that to be yf minus y naught, is going to give us the distance between the starting y position and the ending y position. So this is one that I would use to solve this problem that we have. So we'll just go ahead and write it out here. We have the final velocity squared equal to initial velocity squared plus 2 times the acceleration, and then the difference between the y final and y initial. And so what we're going to do next is just solve for this difference here. So we have y final minus y initial is equal to final squared minus initial squared over 2 times the acceleration. Again, note this could be exchanged with any single variable. We could use delta y, anything like that, or just h if you prefer, but this kind of helps keep everything straight for me. So now that we have this all solved, let's go ahead and plug what we know. The final velocity squared is going to be 0, because at the peak of its flight, it's going to be just stopped in air. So you can think about the y component, or the y motion of a flying thing, to be just if you throw a ball, or if you were to shoot this arrow straight up, you can separate the y and the x components in your mind and think, okay, well, when I shoot or throw something straight up in the air, it goes up and it slows down, it starts slowing down, and then at one point it stops. It kind of seems to hang there for a second. That's because it hasn't started going down yet, but it isn't going up anymore. So this is by definition the highest it will ever be. So at this point, the final velocity, or that snapshot at that highest point, the velocity is 0. So we're going to have 0 squared minus the initial velocity squared. Now this will be the y component of this velocity here. That's 8.9 meters per second squared, or meters per second, but the quantity squared, and over 2 times the acceleration. And note, there is a negative sign on this acceleration due to gravity because we have defined down to be negative. So since the acceleration is down towards the ground, the acceleration will be negative. So we have 8.9 squared comes out to be about negative 79.2 over negative 19.6. And notice these are going to cancel at the end, so we're left with the delta y being about 4.04. And that is going to be in meters. So, to recap, first we looked at the problem we had. We decided that we could use kinematics to solve it, but we would need to change it up a little bit. We split it up into x and y components so that we were able to use the kinematics that we knew, at which point we found the y velocity. We found the ideal formula for what we needed to do with all the knowns that we have and the unknowns that we needed. We solved for the variable that we needed. Then we just plugged the knowns and found the unknown. So the maximum height that the arrow will reach is 4.04 meters above where it was launched. Now, one thing to keep in mind that your professors may throw in there to try to trick you is that the archer, let's say we drew the archer right here, if the archer is shooting it from this point, this height right here may need to be factored in. So keep an eye out. If there are any other heights in the problem that you don't really know what to do with, make sure you keep an eye on that, because if there was a height, say if this problem asked the initial velocity of the arrow is 13 meters per second and the archer is 2 meters tall, then you might have to add 2 meters on top of this 4.04 meters that we found previously. So just keep an eye on that when you're reading your problems. Well, thank you for watching. If this video was helpful, please leave a like. If you would like to see different videos or different problems, please leave a comment. And if you would like to see more physics help, then please subscribe. Have a great day.